Hi, I'm Ayappan and I'm a Senior Development Engineer with the Agilent Technologies 89600 VSA software. If you're a design engineer working on next generation LTE base stations, you should pay attention. Having worked with customers like you, I know firsthand the kind of challenges you are facing with every new release of the LTE standard, with MIMO, beamforming, and carrier aggregation. Only Agilent Technologies has the software and hardware that uniquely suit your LTE design challenges. In this video, I will demonstrate the new 8x8 MIMO capabilities for design, analysis, and measurement that will keep you one step ahead of the rapidly evolving standards. I will show 4 unique 8x8 measurement capabilities in this demonstration. First, we will use the SystemVue software to model an ideal 8x8 MIMO transmitter and analyze its signal characteristics with the 89600 VSA software embedded within the SystemVue model. Next, we will use the SystemVue model to download the 8x8 MIMO signals to 8 vector signal generators. Next, we will analyze the signals playing out using our N7109A 8-channel analyzer and the 89600 VSA software. And finally, we will use the N7109A analyzer and the 89600 VSA software to analyze a problem in one of the frames. First, let's use Agilent SystemVue to model an ideal 8x8 MIMO transmitter and analyze its contents using the 89600 VSA software. You can see here that the SystemVue workspace comprises of multiple blocks. The key blocks here are the LTE advanced downlink source, the 8 modulators for the 8 transmit channels, and the 89600 VSA software. If I zoom in on the LTE advanced downlink source, you will see that you can configure many of the LTE parameters. I'm creating an LTE advanced FDD signal at 5 MHz, and the number of transmit antennas are set to 8. There are 2 users who each use 8 layers, and this signal will be an 8-channel baseband IQ data. The 8 output channels from the LTE advanced downlink source now get modulated and put onto the appropriate center frequency by these 8 modulators. And subsequently, the data gets pushed onto this 89600 VSA block, whose configuration properties can be entered by just double click on the block. 2 key items to notice here are the continuous mode is set to yes, which means that the 89600 VSA software will run continuously as long as SystemVue keeps pumping data into it, and the setup file, which configures the 89600 VSA software for an LTE advanced measurement. Now that we have set up the SystemVue workspace for an LTE advanced simulation, all that remains to do is to run the analysis, which will launch the 89600 VSA software and start pushing data into it. Here is the 89600 VSA software that is now starting to receive data from the SystemVue model. You will notice that when it starts off, the data is not complete, and therefore the demodulation is not successful. But as time goes on, when the data received is a complete frame, 89600 VSA succeeds in completing an 8x8 MIMO analysis. You can see here that the 8 layers of each user are being displayed after demodulation. A few items to note here are the EVM. This is the overall composite EVM across all the channels. This is a very small number of 57 millipercent that you can expect only from ideal simulation signals. The second thing to notice is the MIMO OFDM channel frequency response, which is the channel frequency response of each of the paths from the 8 transmitters to the 8 receivers. This being an ideal simulated signal, all the paths are equal in amplitude and in phase, and that is why you see a single line which actually comprises of 8 channels superimposed one on top of another. You will also notice in this MIMO info table that the relative amplitudes of the channels are very close to each other, and so are the phases and the time offsets. Now that we have analyzed an ideal simulated signal using the 89600 VSA software, it is time to download these signals to the 8 vector signal generators. You would do that by enabling these signal downloader blocks on SystemVue workspace and by disabling the 89600 VSA software. I have written a small script that will download these signals to the sources and synchronize them and play them back in a time synchronized manner. All you need to do is to click this play button that will download all the signals to the 8 vector signal generators and have them play the signals back in a time synchronous manner. We have a new instance of the 89600 VSA software that is analyzing the data that is acquired by the N7109A Multi-channel Analyzer. Again, the same 8x8 MIMO analysis is being performed by the software. A few things to notice and to contrast with the simulated signal that we saw earlier are the EVM, which is about 1.3%, that is more characteristic of real-world devices, and the MIMO channel frequency response, which displays significant differences in amplitudes and phases between the antenna elements. You will also notice in the MIMO info table that the paths have significant differences in their amplitudes and phases. A key thing to note here is that sometimes the analysis succeeds, while at other times it fails in completely demodulating the signal. In order to see what is going on with this failed demodulation, we should see the error vector time trace on the 89600 VSA software. You will notice that when the analysis succeeds, the error vector time trace looks perfectly normal, while when it fails, the last subframe of the frame being analyzed has very bad EVM. The reason for that is a deliberately introduced impairment in the signal that causes the last subframe of the frame to have timing related issues. And in order to drill deep down into that signal, you can use triggering to make the 89600 VSA software capture that portion of the frame at all times. Here I am using an external trigger with a trigger delay of -10 milliseconds that will cause the 89600 VSA software to always analyze the bad frame. In order to go back and continue to analyze a good frame, all you need to do is to set the trigger delay to 0 milliseconds. And that will cause the 89600 VSA software to always analyze the very first frame, which is a good frame. It is instructive to compare the performance of a real-world signal with a simulated analysis that is created in SystemVue in terms of EVM, the MIMO channel frequency response, and the MIMO info table. It is also possible to introduce impairments within the SystemVue schematic to simulate real-world scenarios. The triggering capability is just one example of the powerful troubleshooting techniques that are inherently available in the 89600 VSA software. Agilent provides new and unique 8x8 MIMO features for simulation, measurement, and analysis. SystemVue software is the ideal simulation and analysis environment. 89600 VSA software provides a complete analysis tool, while the N7109A 8-channel analyzer is a perfect RF tool for 8x8 MIMO, carrier aggregation, and 8-channel beamforming. Taken together, these 8x8 MIMO capabilities demonstrate Agilent's commitment to helping you stay one step ahead of the rapidly evolving LTE standards. For more information on these new 8x8 MIMO features, please visit the Agilent website. Thank you for watching.